Okay, guys, so we're going to put it all together and actually start to sketch some of these rational functions, but now we know how to find all the parts of it. So we're going to go through a couple more things and then go through some examples in the next couple of videos. So one of the things that we can also take into account when we're doing our graphs is to look for symmetry. So there's certain type of symmetry that occurs with even functions. Even functions are symmetric to the y-axis. So when it comes to sketching, if you can identify a function as being even, then it can save you some time when you're doing the sketching. It's not always going to happen, but it's just something that could save us some time. When we did graphing trig functions, we noticed that cosine was an even function, which was symmetric to the y-axis. And all that means is that if you replace x with negative x, you actually get the same function. All right, so you can do this with a number if you're not sure. So usually I like to use 2 and negative 2. If I plug it into the function, I get the same answer. It's usually a good idea that it's going to be even. You can pick another number as well, like 3 and negative 3. If you get the same answer, then it's going to be an even function. Odd functions are when you replace x with negative x and you get the opposite answer. Okay, so if you replace x with 2 and get an answer of 5, and then you replace x with negative 2, you should get negative 5. All right, that's usually a good rule that it's going to be odd. And odd functions are symmetric to the origin, which basically means they have 180-degree rotational symmetry. And again, it's just a shortcut, but it doesn't always happen. But if you can identify it, it can save you some time. So just looking at these two examples, if we were trying to identify them as even, odd, or neither, for this first one, you could replace x with negative x and simplify, or you could simply pick a number. For example, if we pick the number 2, 2 squared is 4, 4 times 5 is 20, so we get 21 on top. 2 squared on the bottom is 4 plus 5 would be 9, so we get 20 over 9. Now, if you replace x with negative 2, you'd have to square it first. So you're going to get positive 4, so 21 on top, and then on the bottom, you're going to get 9. So for both of those, we're going to get 21 over 9. I may have said 20 earlier, but this means that it's going to be an even function. So there will be symmetry to the y-axis. Down here, if we replace x with 2, on the top, we're going to get 1, and on the bottom, we're going to get 8 minus 2 is 6, so we get 1 over 6. If you replace x with negative 2, you get negative 3 over negative 8 plus 2 would be negative 6. So that does not give us the opposite answer, and that would just be neither, which is going to happen a lot of times, but it's not a bad thing to look for. So when we're going through our sketching, these are the steps that we're going to go through when you're trying to sketch the graph, okay? Because we're not just going to type it into the calculator and get the graph. That's going to be pointless. So the first thing we would do is check for symmetry. Is it even, odd, or neither? Then we're going to go through and find any x and y intercepts that exist. Then we can identify any vertical, horizontal, slant asymptotes or holes, which we were talking about yesterday or Monday. And then the last thing we would do is make an XY chart for additional points if needed. And usually we just need the sign of the Y value. You can pick anything you want for X. Getting the sign for Y is usually going to give us a good rule for that. So let's look at our first example. So we've got x over x plus 3 squared. So the first three things that we're looking for: symmetry, intercepts, and holes. So symmetry first. If you replace x with 2, so you get 2 over 5 squared is going to be 25. If you replace x with negative 2, we get negative 2 over 1 squared. So that is not going to be opposite signs. So there's no symmetry here. Intercepts, all right, we're going to replace x with 0 and replace y with 0. We actually get that 0, 0 is the x and the y intercept. It's the only point that can be both. And for the holes, there's not going to be any because there's no factors on the top and bottom that are going to cancel. There's no values of x that make the top and bottom 0. Then going through our vertical, horizontal, and slant asymptotes. So our vertical asymptotes is anywhere the denominator is 0. So that's going to be at x equals negative 3. Horizontal asymptotes, since the degree of the top is less than the degree of the bottom is x squared, the top is just x. We get y equals 0. And then for slant asymptotes, we can only have horizontal or slant, not both. And so therefore we're going to have none. That only happens when the degree of the top is 1 more than the degree of the bottom. So if we put this all together on a graph, so if we sketch in the asymptotes and then the points, just to kind of show you this graph. So x equals negative 3, y equals 0 is a horizontal, which we do cross. You can cross a horizontal asymptote. So we actually cross at the intercept, but then as we go on to infinity, we approach it from above. All right, so we do cross there. All right, here we go down to negative infinity. And then to figure out which part of the graph is on here, we just have to take a value on this side and plug it into the function and realize we get a negative.